Section 7.2 is a review of Chapter 6, Solving for Equations. The only difference is now they also say, and write the general solution. So we're going to solve this equation from negative 360 degrees to 0. And then we're going to write this general solution. Now, one of the things that we're going to do when solving, so this one, you want to solve for sine. We've got sine on both sides. We've got numbers on both sides. We're going to combine some of our like terms. Can you see that if I bring the 5 over to this side, I'd have 2. If I bring the 2 sine x over to the right side, 4 sine x minus 2 sine x would be 2 sine x. Divide both sides by 2 to get sine x by itself, and I get sine x equals 1. This would be a non-calculator question because 1 is on your pie plate. So when do we have the y-coordinate equal to 1? At 90 degrees, right? And now this is in this pi over 2, but this question's in degrees. So you would probably say 90 degrees. And this is going to happen, well, this is sort of the process that I'm going to use and I think you're going to use because about 80% of the questions, maybe 90% of the questions are always between 0 and 360 or 0 and 2 pi. That's taking your unit circle and going once around in the positive direction. So where's the y-coordinate equal to 1? Well, that's up here. That's at 90 degrees. Okay? Now, when we look at this question, though, the domain says, look from negative 360 to 0. So that's once around in the negative direction. So the answer will be the same place, coterminal with 90 degrees, just in the negative direction. So we might say, oh, this isn't actually part of my domain. My actual answer is, what would be coterminal with 90 degrees if you're going in the negative direction? Negative 270 degrees. It says, then write the general solution. Well, how do we write a general solution? We write a general solution by first finding all of our answers between 0 and 360 or 0 and 2 pi, which we only have one, 90 degrees. And then we add 2k pi in radians and in degrees. The equivalent to 2k pi is 360 degrees times k, where k is an integer. Part B, use algebra to determine the general solution of the equation cos 3x equals negative 1, and then list the answers between negative 2 pi and 0. So in part B, they asked us to do the general solution first. Cos 3x equals 1. We're going to use the general solution strategy that we did, that we listed before. The general solution strategy we listed is first solve between 0 and 2 pi like normal. So if I was solving this between 0 and 2 pi like normal, and then after I do that, add 2k pi. What kind of question is this, though? With the 3x inside? Do you remember what we called these ones? We gave them a special name and everything. Multi-revolution question. So, for a multi-revolution question, if you're solving between 0 and 2 pi, for 1x, then 3x's would be between 0 and 6 pi. When is cos equal to 1? When is your x-coordinate equal to 1? At 0 and 2 pi, that's the first time around. 4 pi would be the second time around. 6 pi would be the third time around. Was it -1? Did I copy it down wrong? Yes, thank you. Well, let's do it right. If it's -1, that happens at pi on the first time around, at 3 pi on the second time around, and at 5 pi on the third time around. So solving for x, x would equal pi over 3, just pi, and 5 pi over 3 after we divide each of those answers by 3. So then our general solution would be x equals each of these 3, pi over 3, pi, and 5 pi over 3, and we're in radians, plus 2k pi, plus 2k pi, where k is an integer. If we wanted to list the answers between -2 pi and 0, we have our answers between 0 and 2 pi, right? Those three answers are our answers between 0 and 2 pi. If we had to list our answers between -2 pi and 0, we have to say, what's coterminal with pi over 3? If I go in the negative direction. So here's pi over 3. I'm going around this way. That would be -5 pi over 3. What's coterminal with pi? If I'm going in the negative direction, that would be -pi. And what's coterminal with 5 pi over 3 in the negative direction? That would be -pi over 3. Questions 4, 8, and 9 for practice.